good?
Good.
Yeah. Okay, I'm ready. Okay, good morning everybody. So today we'll learn sight distance. It is related with traffic engineering. And so what is sight distance? First you need to know what is sight distance. Sight distance is the length of roadway ahead visible to the driver. So when you are driving a car, you can see long distance, that is your sight distance. Okay. So it is fundamental that the driver can see sufficiently ahead to avoid any accident or any hazard. So, and if it is a two-lane road, like Kelowna Road, you need to see long distance ahead to overtake or passing another vehicle. So that is called passing sight distance. We'll come to that point a bit later. So see these two figures. Actually, I took this figure yesterday from my car. So you can see this one, you have noticed this one on road, PPR to stop. There is no PPR to stop. Although light is there, you can see the light, no PPR to stop. Can you tell why? Do you know why PPR to stop is sometimes there, sometimes not there?
Speed?
Yeah, it is related with speed, one, yeah, good.
Not enough
There's
sight
no-
distance.
Yeah, not enough sight distance. This has enough sight distance.
Like
And
we can
the
see
speed is
second
low.
light.
This side, not enough sight distance or speed is high, maybe. So if there are any curve on the road, you don't have enough sight distance, then they will give this sign. Or you are on a highway, freeway, your speed is very high, and traffic light is there, especially if you go Trans-Canada Highway where traffic light is there, you'll see this type of sign. So what you'll do if you see this type of sign?
That's slowing down.
Yeah, you have to brake, okay? And if you brake here, you have to stop before the light. That is called stopping sight distance, okay? So if you see this thing here, they didn't put it arbitrarily anywhere. It has some calculation. So we learn how to calculate this distance. It is not just arbitrarily you cannot put, it's a design one. They know that if your speed is there, you need this distance to stop before the light. So how to calculate this stopping sight distance? We'll do that one today, okay? Now objective is clear? So yeah, that is stopping sight distance. Actually, sight distance, so this is the learning objective. We'll learn actually different type of sight distance. Due to time limitation, I'll teach you how to calculate only stopping sight distance. Okay. Three types of sight distance are there. One is stopping sight distance that I mentioned already, this type of things. One is passing sight distance. It is a two-lane road. You will find this type of situation if you drive towards Kelowna. Okay. And another one is decision sight distance. If suddenly something happened in front of you, so there is a reduced cross section of road, or there is some construction zone, then you have to put decision sight distance. Okay. So these three types of sight distance are there, but we'll calculate stopping sight distance today. So how to calculate stopping sight distance? To calculate stopping sight distance, you need three things: perception and reaction time, operating and design speed, and coefficient of pavement friction. These three things you need also to calculate sight distance, but it is for slopey road. We'll not consider slopey road today. We'll consider only straight road, okay? Or some horizontal curve is there. So these three, and these three you know it today, only these three criteria you have to address to calculate the sight distance. So what is stopping sight distance? If you see some hazard in front of you, what we'll do? You need some time to react. And that is called reaction distance or perception distance. Then you put your brake. When you put your brake, the car will not stop. It will go some distance. That is called braking distance. If you add together these two, that will give you the stopping sight distance.
distance always the same for every person?
No, it is not same. That I'll mention later. So reaction distance or perception time, thank you. Perception, this is reaction and perception. So we can calculate this using some formula, empirical formula is there, 0.278 V and T. V is your car's speed. So this V is your car speed. It can be design speed or initial speed or what speed you are driving. And T is the perception time. This perception time varies. Your perception time, my perception time is not same. Do you have any idea what will be the perception time for you? If you see something, then you have to react. Generally, normal people take 2 seconds. Or some smart people take 0.75 seconds. But for our design purpose, we are a bit conservative. We take a 2.5 seconds. But if you design the road in a community where a lot of old people or disabled people are there, then we put it 4 seconds. Okay. So this perception time varies 2 to 4 seconds. Generally for the design, for normal young people, smart people, it is 2 seconds, and old people it is 4 seconds, but for normal use we take 2.5 seconds. Okay. So perception time you can calculate this 0.278 VT, and braking distance, this is another, V is the speed and 254 F. This is some empirical formula, I will not go on the formula, but you should know this F is the friction between your car and road. Friction factor, how will get it? You will get it from the TSC manual. Yesterday I mentioned that manual give you different speed, different friction factor. So I give you a sheet. So if you add these two, you will get the stopping side distance. So you already know this V is the speed of your vehicle and T is the perception time, and this friction factor will come from TSC manual. Let's check we can calculate or not. So consider a road. Yesterday you learned the road classification. RAU 110. That means what?
Rural,
Arterial,
Undivided.
undivided, and speed is 110. So you need actually the speed to calculate here. Another thing you need, friction factor. So when the speed is 110, you can get this, what is the friction factor?
0.28.
28. So you can calculate actually, this is the formula. You just put in the formula 110 square, this is 0.28, and this is your perception time. Then you will get your stopping side distance will be 246 meter. Okay. So you can, if it is that type of road, stopping side distance, that means your traffic light is here, you have to put the sign here. Okay. And whether your calculation is correct or not, you have to check with the guideline or manual. So if you go to the next, this one, you can see your guideline 110 speed, it is within that range. So your one is 246, that means your calculation is correct. So you can put that one. If your thing is outside this range, something wrong with your calculation, or you have to take some value from here. Okay, this is the guideline. The tech manual will give you the guideline. It will not give you the exact value because it is manual, it is not standard. So you have to take the value. So your one is 246, that means you can find you can fix that 246. You can use 250 maybe to put your alert system. So what we learned, there are different type of side distance used in road design, and you have learned how to calculate the stopping side distance on tangent road, on straight road. On curved road, a bit different actually. So thank you. And if it is a curved road, then you have to use actually the friction factor will be different. Friction factor will be slightly different, so you have to use another table to find another friction factor. It is same calculation, but instead of this F, you can see, as I have few seconds. This F, you have to use F1, and that one you will get from the tag manual. Awesome. So thank you.